All right, guys, we are going to go over solving exponentials. I think I have like 9 examples or so. Each one is a little different, so it's really good to pay attention to what I'm doing and watch how we do this. But the biggest thing that we can remember from this is that exponentials and logs are inverses of each other, right? And ln and e to the x are inverses. And when you solve equations, how do you get x by itself? You do the inverse operation, right? Mm-hmm. Okay, so if we can remember that, we're going to be okay. What you're going to want to do is rewrite your original equation in a form that allows you to use one of the one-to-one properties, which is above here. If you can't do that, then you are going to just simply solve by using inverse operations, okay? Look here. This is how you guys should attack these problems, all right? We're going to look at A. I have e to the x equals 72. First thing you should do is look and say, okay, e to the x. What is the opposite of e to the x? ln, right? So you want to isolate your function. I want to get e to the x all by itself. Is it all by itself? Mm-hmm. Yes. So if this said plus 5, you would subtract 5 from both sides. If it said times 2, you would divide by 2. So what did you guys just tell me the opposite of e to the x is? ln. So I'm going to take the natural log of both sides. What you do to one side, you have to do where? To the other, all right? What happens when you have ln and e together? What do? They cancel each other out because they're inverses. So I have x equals, now in your calculator, hit ln 72. Round to 3 decimal places. Hit the ln button, 72. And then hit 4.277. What do you guys get?
72.
72, right?
3.8.
Give me 3 decimal places.
3.878.
Can we check this? Yes. Take this and put it right back in right there. So you would hit in your calculator 3, parenthesis, 2, raise it to the 3.807, close your parenthesis, and hit equals. What do you guys get? Every single time you guys get an x equals, you can plug it back in and make sure that your answer is correct. Does that make sense? All right, so let's go to number 3. Do you see your function? Do you see e to the 2x? Everybody see that? So the first thing I'm going to do is I'm going to identify my function. This is what kind of a function? It's an exponential. It's a special one. It's an e to the x, right? What's the opposite of e to the x? ln. So at some point you're going to use ln. But I have to get that e to the 2x all by itself. So what am I going to do? I'm going to add 3. So add 3 to both sides. So I have 4 e to the 2x equals 5, right? I still need to get e to the 2x by itself. So what am I going to do? Divide by 4. So I have e to the 2x equals 5 over 4. Just leave it. Don't do anything in your calculator yet. Just leave it. I have e to the 2x. What is the opposite of e? You guys just told me. ln. So if I take the natural log of this side, what I do to one side, I do where? To the other. What happens with ln and e? They cancel out. What am I left with? 2x equals, in your calculator, put it in just like this. Hit ln and then do 5 divided by 4 and close your parenthesis. What do you guys get? 2.22314, something like that?
Yeah.
All right. Now how do I solve for x?
Divide by 2.
I divide both sides by 2. So divide by 2. Just hit divided by 2 in your calculator. What do y'all get? 0.112. Perfect. Can I check this? Absolutely. You can take this 0.112 and plug it in right there. You can do all of that, in your calculator. You don't have to do anything, you don't have to write anything down. You can just plug that back in and make sure that you get something really close to 2. I told you guys yesterday, when you're solving these, there's only one step that has to do with trig stuff. Not trig. Yeah, this is trig. There's only one step, and it's undoing either the exponential or the log. All right, so again, we're going to do the exact same thing every time. I'm going to isolate my function. When I do this problem, I'm going to replace t with x. But I have an exponential. Does everybody see this is an exponential function? What's the opposite of exponential? Log. So at some point, you're going to have a log. What log little base are you going to use? Yep, log base 3, because the big base is 3. But I need to get that yellow that I've highlighted all by itself. So the first thing I'm going to do is what? Add 4. So I have 2 times 3 to the 2x minus 5 equals 15, right? Now what? Divide by 2. So I have 3 to the 2x minus 5 equals, I'm just going to leave it as 15 divided by 2. You don't have to do anything yet. Now, what did you guys just tell me? What is the opposite of an exponential function? Log. What log little base am I going to use? 3, so they cancel out. So if I use log base 3 on this side, what do I do on the other side? Log little 3. So here this cancels out. This comes down. 2x minus 5 equals, in your calculator, guys. All right, this is a change of base. How would you put this in your calculator?
Divide logarithm, the big number by this.
Okay, so you're going to say log of 15 divided by 2. That's visually the bigger number, right? That's also 7.5. Divided by what? Log 3. So do that in your calculator. Okay, so you got 1.834. Now, do you know how to solve the rest of this equation? Yeah, of course you do. You guys have done this a million times. You're going to add 5 to both sides. So 2x equals 6.834. And then do what? Divide by 2. Perfect. So x equals what?
3.41.
And what can I do with that to make sure that I'm right? I can plug it right back in. All right. Okay, now we're going to get a tad more complicated, but nothing you guys can't handle. This first one says natural log of 3x equals 2. Can I divide both sides by 3? Why not? Do you see how the natural log and x have the 3 in the middle? They're stuck together. You can, if the 3 was out in front, yes, you could divide, but you can't. That natural log is stuck with 3x. So it's already by itself. So what is the opposite? Look at your calculators. What is the opposite of ln? E to the x. So what you're going to do is you're going to use e as the base. So you have e, whoops. We have e, and then everything goes in the exponent. E becomes your base, and ln 3x goes to the exponent. And what you do to one side, you do where, guys? So I have a big E, and then what goes in the exponent? 2. On the left-hand side, what happens with E and ln? They cancel out. What are you left with? 3x equals, guys, in your calculator, what is E to the second power?
7.389.
Perfect. And then how would I get x all by itself? Divide by 3. So x equals 2.463. Perfect. Let's look at B. We're going to go through all these examples, and then we're going to practice this the whole bunch. Look at B. Okay, so I'm going to rewrite B. It says log little 3 of 5x minus 1 equals log little 3 of x plus 7, right? What do you guys notice here?
The logs are like the same.
The logs are the same. All right, this is a special case. When you have one log on the left-hand side and one log on the right-hand side that are exactly the same, what do you think we can do to them? You can just cross them off. If you have one log with little base on the left-hand side and one on the right-hand side, if you have more than one, you got to condense it or something first. But if you have one on one side, one on the other, you can just cross them out. And now, do I know how to solve this equation? 5x minus 1 equals x plus 7. So what do I do? Okay, so let's subtract x. So I have 4x minus 1 equals 7. Add 1. 4x equals 8. Divide by 4. And x equals 2. Okay, now, you're going to have equations, you're going to have problems, and it's going to say, make sure you check for extraneous solutions. What does an extraneous solution mean? It doesn't work. Okay? When you have an extraneous solution in a case like this, it's not because the numbers are weird or anything like that. An extraneous solution is going to be when you plug something in your calculator and you get an error message. That will happen with this case. Write this down. You cannot take the log or natural log of a negative number. Now, I don't mean that x equals -2. I mean that if you plug it back into your parenthesis, you get a negative number. In your calculators right now, hit log of -6. What does it say? Error. All right. Hit ln of -4. What does it say? Error. You cannot take the log of a negative number. So when you get something like x equals a number, and it has to do with logs or natural logs, right? This is the first one we did with log or natural log. You have to just make sure that you don't get a negative log. So what you would do is you would take 2. Look, just think in your mind. If I put 2 right here, what's 5 times 2? 10, and 10 minus 1 is 9. Is that a negative? No, so you're good. What about on the right-hand side? What is 2 plus 7? 9. That's not negative, so you're good. That's all you have to do to check it. You don't actually have to plug it back in and check in your calculator. You just have to make sure that the value in the parenthesis would not become a negative number. Does that make sense? Really important that you guys see that. We have to check for extraneous solutions, ones that don't work. Do you have any more? Okay. All right, let's look at what we're working with. What do we have right here? ln. So think about it, all right? I got to get this ln of x by itself. What is the opposite of ln? E. So at some point I'm going to use an e. But I have to get that ln x by itself. So what's the first thing I'm going to do? Subtract 5. Good. So I have 2 natural log of x equals -1, right? Now what? Divided by 2. So I get the natural log of x equals -1/2. Agreed? Okay, so now the natural log is all by itself. So what is the opposite, guys? What did you just tell me the opposite of natural log is? E. So I'm going to put a big E, and everything goes in the exponent, right? What you do to one side, you do where? So I put a big E, and then what goes in the exponent? -1/2. Perfect.
So it wouldn't cancel out?
It will, yes. E and ln do what? They cancel. Good job. So I have x equals, and in your calculators, guys, just hit second ln, and then put in, you can put -0.5, or you put -1 divided by 2. Close your parenthesis. What do you guys get? 0.6065, 607, something like that. There you go. If you guys are going to get yourselves confused, just think about it. Put it in your calculator. If your calculator tells you an answer, then you're okay. So I got x equals 0.067. So think about it, right? when you get your x equals, when you have logs or natural logs, you have to make sure that either your log or natural log is not negative. So if I say right here, ln of 0.607, is that a negative number? No. If you want to check in your calculator, hit ln and then put 0.607. Do you get a number? We got negative 0.4999. Is that close to negative 1/2?
Yeah.
There you go. This is not terrible. It's just a matter of remembering what are inverses of each other and how to undo. 3 more. Okay, let's look here. I cannot impress upon you enough the importance of get a marker, get a highlighter, circle. Make sure you isolate your function. Do you guys see how log 5 of 3x? That 3 is stuck in between the log 5 and the x. You cannot divide by it. But I can do something to get log 5 of 3x by itself. What would that be? Divide both sides by 2. Good. So I have log little 5, 3x equals 4 divided by 2 is 2. All right, so what's the opposite of logs, guys?
Exponents.
Exponentials, right?
So can you just do 5?
So what's going to be my big base? Instead of a big E, what's the big number I'm going to write?
5.
Why is it 5?
This is the
Alyssa, my handwriting was weird. But why am I going to use 5? You're right.
Just do.
You're right. Reese, tell me why.
because it's a little.
Because it's the little number, right? You want them to cancel out. So I'm going to write 5. I always do this exaggerated. I write a big 5, and then everything else goes in the exponent. And what you do to one side, guys, you do where? So I write a big 5, and what goes in the exponent? 2. Perfect.
You would keep the 5.
So what happens with 5 log 5?
Oh, I just did.
They cancel out,
I just did.
and I'm left with what? 3x equals what? 25. 5 squared. And then do what? Divide by 3. So x equals, what's 25 divided by 3? 8.333. Okay. Can I check that? Yeah. If I plug 8.33333 in for x, is that going to give me a negative number? No, I'm going to multiply it by 3. It's not going to make it negative. All right, let's go to numero 9. Ooh, geez. Here we go, Mrs. Meadows. Okay, what was that rule we just had a second ago? If there was one log or natural log on one side and just one on the other, what could we do? We can cancel them out. Okay, I can't cancel all of these out because it has to be one on one side and one on the other. Did we learn something yesterday or the day before that could help us smush together the left-hand side? How can we multiply those together? Good. Can we condense the left-hand side? Do they both have the same log or natural log? Yes? So I could rewrite this as ln of, when I'm condensing, addition becomes what? Multiplication. So x minus 2 times 2x minus 3. Agreed? And then what can I do on the right-hand side to condense that?
Divide by 2.
Not divide by 2. What is 2 in that case? It's a coefficient. What would it become when I condense? An exponent. Good. So this would become ln of x squared. All we did was just condense it. We just smushed it back together. And we can do that because the natural logs on the left-hand side are the same. If it was log 5 and log 2, we couldn't do that. But since it's both natural logs, we could just smush it back together. So now, do I have one natural log on one side and one natural log on the other? Yeah? So what can I do to them?
Cross
I can just cross them off. And what do I have now? I have a basic factoring problem that you guys have done 100 times. FOIL this out. X times 2x is 2x squared. X times minus 3 is negative 3x. Negative 2 and 2 is negative 4x. And negative 2 and negative 3 is plus 6, correct? Equals x squared. Now what do I do?
Combine like terms.
Okay, so 2x squared minus 7x plus 6 equals x squared. Now what? Well, hold on one second.
Do we square it now?
I have to subtract x squared. Good. You want to get all of your variables on one side since it's a quadratic. So x squared minus 7x plus 6 equals 0. Are there factors of positive 6 that multiply to give me 6 but add to give me a negative 7? What are they? X minus 6, x minus 1. Agreed? So when I solve this, I get two answers. X equals 6 and x equals 1, right? Yes? Since I'm dealing with logs and natural logs from the very beginning, what do I need to do with those two numbers? I got to check. What do I check for? Am I going to plug it back in and solve this whole thing? What's the only thing I need to check for? If the parenthesis is positive. So if I take 6, just think about this. If I put 6 here, what's 6 minus 2?
4.
4. Okay, that's a positive number. If I put 6 here, what's 2 times 6? Minus 3. 9. Okay, that's a positive number. And then here, can I take the natural log of 6? Yes. Okay, so 6 works. 6 is good. You guys understand that?
Yeah.
Okay. So now let's plug in 1. If I plug in 1 right here, what's 1 minus 2?
Negative 1.
Ooh, I get a negative number. So what do I know that x equals 1 is?
Doesn't work.
It doesn't work. It's extraneous. You guys have to do that. You have to either tell me that's extraneous, cross it out, do something to let me know that you understand 6 works and 1 doesn't. Everybody see that? We okay? All right, one more problem. I don't think this is on your notes, so go ahead and write it down. All right, this is a problem that we haven't seen. We haven't done any like this. What do you guys notice about this problem?
Exponents.
Okay, there's exponents, good. What else do you notice? There is subtraction. How many e's do you see?
2.
2. We haven't done any where there's 2 e's. Guys, this is an exponential quadratic. All right, what did we just do here with our quadratics? We got everything to where? To one side. Okay, same thing goes here. Do you see how you have e to the 2x and then you have e to the x? This is just a quadratic problem. So let's move everything to one side. So I have 2e to the 2x minus 9e to the x. Then what does 5 do? Okay, minus 5 equals 0. If I gave you guys this problem, could you factor it? What would you do?
Multiply the 5.
A times c, so 2 times negative 5 is negative 10. What are the factors of negative 10? That multiply to give me negative 10, but add to give me a negative 9. Negative 10 and positive 1, right? And then a is not 1, so we would divide both sides by 2, correct? Guys, this is the exact same problem. The only thing that's different is it has the e's. This is just a basic factoring. Now you're wondering, how come it's not e to the x squared? If I have e to the x times e to the x, what happens when you are multiplying and you have the same base? What do you do to the exponents? You don't cross them out. What do you do to the exponents? You add them, right? So this becomes e to the what? Not x squared. It becomes e to the 2x. That's where this e to the 2x came from. So instead of just putting an x in the front of your parenthesis, what do we put? An e to the x. And this is just a basic factoring problem like you guys just walked me through. This would be minus 10 and plus 1, right? 2 times negative 5 is negative 10. What multiplies to give me negative 10 but adds to give me negative 9? We do the exact same process. My a term is not 1, so I'm going to divide both of these by 2. So over here, I have e to the x minus 5, right? Agreed? What's the second parenthesis say? 2e to the x plus 1 equals 0. Do I now have two exponential equations? What do I do with each parenthesis now that I have it simplified? Set it equal to what? So I have e to the x minus 5 equals 0. And I have 2e to the x plus 1 equals 0. When I solve this, on the left-hand side, how do I get e to the x all by itself? I'm going to add 5. So I have e to the x equals 5. On the right-hand side, how do I get e to the x by itself? I'm going to subtract 1. So I have 2 e to the x equals negative 1. Then what? Divide by 2. So I have e to the x equals negative 1/2. Now I have one extra step. If this was not an exponential, you guys would have x equals 5 and x equals negative 1/2. But I have to get x all by itself. I got to get that e to go away. What's the opposite of e, guys? ln. So if I take the natural log of this side, then I have to do what? Take the natural log of the other side. So e and ln cancel out, and I get x equals, in your calculators, what is ln of 5? 1.609. Okay. That's fine. Now on the right-hand side, I have to get e all by itself. So what's the opposite of e to the x? ln. I'm going to take the natural log of the left-hand side. But what you do to the left-hand side, you do to the right. Okay, so guys, in your calculators, hit ln. And then negative 1 divided by 2, or negative 0.5. What do you guys get? Why? Because you can't take you cannot take the log or natural log of a negative number. So what do we do to this side? Cross it out. So we have one answer. Is this horrible? No. This is basic solving of equations. You just have to remember that step of undoing. What is the opposite of exponentials? Opposite of exponential? Logs. And what's the opposite of ln? E. Okay, very important that you guys got that. I'm going to post this now so you guys have